Geometry. This is Miss Rich coming to you from home. We have a quiz coming up, and so I want to go over some of the highlights. I have two videos here. The first one is over to section 1 and 2, which are parts of circles, central angles, and arc length, and then the second video will be on sections 3 and 4. So first, I think you'll have this pretty good, but I just wanted to point out a couple things on naming the parts of a circle. You will have this at the beginning of your quiz. Make sure when you name the circle that you use the circle symbol first. This right here would be called circle B, named always by its center. Radius will be BP or BL or CB. Order doesn't matter there, but those are all segments. So that's not hard. Diameter is made up of 2 radii all the way across the circle, so that would be PL, the segment. A chord. Now be careful, make sure you know the difference between a chord and a secant. A chord is a segment, like LM. It stops only this part from here to here. It stops on the circle. Where another chord would be the segment PL. PL is the longest chord in the circle because it's the diameter. A secant is a line that passes through the circle and intersects it twice. So we could say the secant is also LM, but LM the line, where the chord was LM the segment. So make sure you make that differentiation. Tangent is a line that only touches a circle in one place. So this would be PQ, the line. Sometimes that will look like a segment or a ray, and that's fine as long as you realize that it is the line that can only touch the circle one time. Point of tangency would be P, that's a single point where the tangent line has touched the circle. Central angle is an angle that has its vertex on the center of the circle, and its sides are made up of radii. So that would be PBC. Name it like an angle, PBC. Another central angle that's obtuse would be CBL. An inscribed angle is an angle whose sides are made up of chords and whose vertex is on the circle. So our inscribed angle would be PLM or MLP, either way you want to name it. PLM. A minor arc is an arc that is less than 90 degrees, so we could find like PC here. It's drawn with a little sunrise arc over the top of it. Another minor arc would be CL. It's only named with 2 points. Notice CL is obtuse. It's more than 90, but it's still a minor arc because it's less than 180. Now if it is 180, it would be called a semicircle. Semicircle, PML. Or the other side, PCL. So don't miss those easy questions. Major arc is more than 180 degrees. So make sure, just find 2 points that are close and grab another point around as you're going, like CLP. Only name it with 3 points, CLP. You could have called that same arc CMP, would also have worked. You could do PCM, but make sure when you're naming a minor arc, you're going right along the arc of the circle. Okay, so moving on to central angles. Remember, central angles are equal in measure to the arcs they open to. So if the vertex is on the center, like here, L, VLZ is 100 degrees, so the arc it opens up to is 100 degrees. Remember to look for semicircles. This is 180 degrees, so that would mean this WZ here must be 80 degrees, and therefore its central angle is 80 degrees. We can still use vertical angles like always, so this angle over here would also be 80 degrees, and its arc XY is 80 degrees. This arc KW is 10 degrees, so the angle, central angle making it is 10 degrees. And here, if I look, there's 180 degrees here, so I have 80 plus 10 is 90. So this last angle L must also be 90 to add up to 180 there on that semicircle. So this arc is 90. Notice if you're asked to find a major arc, like perhaps what's the measure of KXW? If you're asked for a major arc like KXW, don't jump across like this. Follow the arc. I could either add 90 plus 80 plus 100 plus 80, all the arcs that make up KXW, or I could just take 360 degrees, the whole circle, and subtract the 10 degrees that I don't want, and that would be 350 degrees for that major arc. So look for those shortcuts. Okay, now be careful if it says find the length of an arc. Arc length is different than arc measure. Arc measure is degrees. Arc length is how long is that arc in inches or centimeters. So they're saying in this circle, in circle L, the radius is 14, and so we want to find the length of WZ, which was 80 degrees in measure. Well, it makes sense if the circumference, the length all the way around, is pi times diameter, or diameter times pi, that the arc length should be a fraction of that. And since this is 80 degrees out of a possible 360, there is our fraction. So our arc length formula is going to be angle over 360 every time times circumference, diameter. The angle is 80 degrees. The radius is 14, which means the diameter is 28. So I'm going to do 80 degrees over 360 times the diameter, 28, times pi. I'm just multiplying fractions here. So I can simplify 80 over 36, get rid of those zeros. They're both divisible by 4, so I could simplify to 2 and 9. So 2 ninths times 28, 2 times 28 is 56, and 9 times 1 is 9. Pi is our answer, and it's pretty common that that's what the answer looks like. KZY. So we need to make sure when we do the angle for KZY, we need the whole arc that would make KZY, which is 80 degrees, 100 degrees, plus 80 degrees, plus 10 degrees. So that's 190 is the angle that makes up KZY. 190 over 360 every time times the diameter, which is 28, times pi. So here, simplify 19 over 36. Let's see, 4 will go into 36 9 times, 4 will go into 28 7 times. So I have 7 times 19 over 9, because 9 times 1, I'm getting a fraction there. Which is 7 times 19, that would be 7 times 9, 133 over 9, and don't forget our pi. Finding circumference. Okay, we know that if an angle is open up to a diameter, it has to be 90 degrees. Here you were given the 90 degrees. Circumference we know is pi times diameter. And so pi times diameter, so we need the diameter. This looks to me like a triple. 3, 4, 5 is the diameter. So circumference is simply 5 pi. So keep that easy by just using your right triangles, triple if you can find one.